Hello everyone. Welcome to question 24 on binary representation of a number. This is Nikesh Agarwal from Sarthi Career. This question was asked by Cisco in a written technical round and it can be found all over the internet. If you look at this question, at the first glance it might look to be a very difficult expression to solve, and we have to count the number of ones set in the binary representation of the final result. And it might take a lot of time to solve this, but considering it was asked in a written technical round, a max time we can dedicate to this question would range somewhere between 30 seconds to 1 minute, which means there must be an easier way to solve this. And you need to look and identify for patterns. And if you look closely, you might find a pattern wherein every digit or every number here is multiplied by powers of 2. So if you look here, this is 2 to the power 12, this is 2 to the power 8, 4 and 2 to the power 0. So let's go ahead and rewrite this expression, so which is 3 into 2 to the power 12 plus 15 into 2 to the power 8 plus 3 into 2 to the power 4 and plus 3 into 2 to the power 0. Now if you remember one of our earlier questions on bitwise operators, you will remember that multiplying a number by powers of 2 is basically left shifting by that many bits. So if I multiply 3 with 2 to the power 4, it's basically saying 3 left shifted by 4 in binary, and this would mean 3 left shifted by 0. This would mean 15 left shifted by 8, and this would mean 3 left shifted by 12. Now let's go and write the binary equivalents of all these numbers. So 3 would be in binary 1 1, so 1 1 left shifted by 12, and then 15 would be 1 1 1 1, and that is left shifted by 8, and 3 would be again 1 1, that would be left shifted by 4, and 3 again, which is 1 1, and that is left shifted by 0. So this is what we get as the final result or expression which we need to solve and count for the number of ones set in the final expression. So let's go and solve this first part. So when we do 1 1 left shifted by 12, we basically get 12 zeros, which means just that we have left shifted 1 1 by 12 times, and you can see here that we have left shifted it by 12 times. And then we have 1 1 1 1, that is 15 left shifted by 8. So we are basically moving 8 steps to the left, and this is what 15 is, left shifted by 8. And then we have 1 1 left shifted by 4, that is 3 left shifted by 4, so 4 zeros and then a 1 1, and then we can just put zeros in the remaining places. And then finally 1 1 left shifted by 0, so this would just be zeros then, because there is no shift. So this is your final binary of the entire expression, and we have to basically add all these binaries. So if you go on adding all these binaries, basically we are going to get 1 here, 0 0, 1 1, 0 0, 1 1 1 1, and a 1 1 again. If I add all the bits set in the number, I would see that there is 1 2 3 4 5 6 7 8 and a 9 and a 10. So 10 ones in the binary representation of the number is the final answer. And if you have to summarize this question, you will see that eventually all that you've done is just adding the bits set in these numbers 3, 15, 3 and 3. So 2 ones plus 4 ones 6 plus 2 8 and plus 2 10. So if you had just looked at this question, it would have been sufficient enough to come up with an answer And the trick here is I am left shifting it in such a way that there is never an overlap of ones here, because if there is an overlap and if you do a plus in binary, you're basically going to get 0. 1 plus 1 is 0, and the find and the carry of 1. So only if there is an overlap of two ones, and if you have to add it, it might result in a complex expression and might take more time to solve. But if in this question we could immediately make out, considering that 3 is left shifted by 12, 15 is left shifted by 8, 3 is left shifted by 4, and 3 left shifted by 0, there will be no overlaps of ones set in that number, and hence we could have just counted the binaries or the ones set in the binary representation of 3, 15, 3 and 3 to come up with an answer. So I hope you guys liked the video. Please do share and subscribe, and please leave comments in the comment box below in case of any suggestions. Thank you.